Good morning everyone, and this is Sangeetha Margaret from Department of Physics, St.Joseph College of Arts and Science, Cuddalore, and here we are going to talk about ensembles in statistical mechanics. So the term which was proposed by Gibbs. So he was the one who proposed the term ensembles. So what is called ensembles? If I can explain you in a general way, I would say a group of members, a group of politicians, a group of dancers, a group of musicians who are, we just talk about a collection of collection of members, collection of systems, who are all performing together. So in this way I would explain this is called ensembles, a collection of members. So in a statistical way, how could I explain ensembles is collection of large number of microscopically a collection of large number of systems, but essentially all are independent systems. So collection of large number of microscopically but essentially independent systems. So this is called ensembles. So in another way I would say an ensemble consists of a very large number of systems, each constructed to be a replica on the macroscopic level. So this is called I would say ensembles. There are three types of ensembles. So in a very first we'll talk about microcanonical ensembles. We'll see one by one later then. Okay, so in a very preliminary way I'm just going to explain what are all these ensembles telling you. So for the first one, microcanonical ensembles. So microcanonical ensembles is an isolated system. So it's an isolated system. If it is an isolated system means there is no exchanges happening here in the system. That is, no such heat energy or no particles. So there will not be any connection to the source and the surroundings. So if this is the system means, if the system will not have any connection with the surroundings, so it is so then we would say it is an isolated system. If it is an isolated system, so no such heat energy or no particles will be exchanged from the system and the surroundings. So here we would say the energy and the volume and the number of particles are being constant here. Here this is the for best example I would say, if a college or a school having identical classrooms with the partitions, isn't it? So here also there is the small systems we are having here with the partitions. There will not be any connection between the two systems. So all are highly isolated here, highly how can I say, uh, each one is here a isolated system. There will not be any connection with the other systems. Okay, so we would call it as a isolated system, microcanonical system. So for example, if I'm going to give you any example for this microcanonical ensemble is I would say thermoflux. We all know the thermoflux. So or a perfectly isolated thermoflux, I would say it's an example for microcanonical ensembles. Seriya? Okay, so second one is a canonical ensemble. So canonical ensembles is a closed system. Okay, closed system means here obviously there is a there is a connection with the system which is connected with the reservoir or surrounding. Anyway, it's a closed system, but then it cannot be isolated or to be an open system, but it is just connected with the surroundings, If it is connected with the surrounding means no particles cannot be exchanged, but the energy can alone be exchanged here. Okay, so whether that is the kinetic energy can be exchanged here, but number of particles would be same. So here I can say that temperature, volume and the number of particles are keeping constant here, and only the energy can be exchanged in the canonical system. Hence I would say it is a closed system. Though it is connected with the surroundings, only the energy can be transferred, energy can be exchanged, but no such particles can be exchanged here. So temperature, volume and the number of particles will be constant here. In this way kinetic energy can be gained or lost. That is, the energy is exchanging here. Number of particles are fixed here, and for example for this canonical ensemble is pressure cooker, tightly closed pressure cooker, I would say, with a whistle, சரியா, on a stove. That is the example for, I can tell you, that is the example for canonical ensemble. Third one is grand canonical ensembles. It is an open system. It is an open system means it has the system will be have some open. The system will be have it will have some open. It is not completely closed. It has, the system itself has some open, and which is also connected to the surroundings. So there is a possibility to exchange number of particles, also the energy. So both can be exchanged. Number of particles can also be exchanged and the energy can also be exchanged. So here temperature, volume and the chemical potential mu can be maintained as constant. I would say here here also the example is pressure cooker, but with the open lid. In the case of canonical, I told you that pressure cooker with the closed lid on the stove, but here pressure cooker with the open lid. So this is the example for grand canonical ensemble. Here we are having temperature, volume and chemical potential being constant, but energy and the number of particles can be exchanged. Okay, so this is micro canonical ensemble. It's a isolated system, and canonical ensemble is a closed system, and grand canonical ensemble is a open system. Okay, so this is for a brief explanation of ensembles. Thank you.